Hi there. This is MD Juman Muntasir. So my partner is Boston. So we have worked on this assignment one. This is for the submission of our assignment one, which is a push to talk signal analysis and demodulation assignment using the GNU software. So I have flow graph. I have beat the flow graph over here. So in this flow graph, I'll work through each block and explain step by step how the blocks been processed. So starting with the file source, here you see in the first there's the file source. So this this uh, like in this block I have added the file which is given by the professor. So this file contains the captured radio signal at a sampling rate of 2.54 megahertz, and I set the repeat yes, so the playback loops continuously when I test. So we're going to test it later, that time you can see. And next I have added a Qt GUI sync, and by observing the spectrum, I found the main spike was offset from the center, a kind of center, which was kind of 1.05 megahertz. I can current right now I can run this, and we're gonna see the spike. So let's say I'm running, and on the left side you can see here is executing code, taking kind of bit.
Good job. You successfully recovered the audio.
So you can see
Now make
the
sure
spike
there is
is
no
over
static
here,
or noise
which
in the
is
signal.
the spike was 1.0512, something like this. So that's why I put 1.05 to be very specific. So that's state. So this is this state shifts like then I used a signal source. You can see that generates a cosine cosine waveform on the frequency with minus 1.05 megahertz, and I multiplied it with the original signal using the multiply block. You can see there is a block multiply block in between our signal source and the low pass filter. Then I have added a low pass filter. So after the frequency shift, the signal passes through a low pass filter. So the cutoff frequency is set to 12.5 kilohertz with a transition width of 2 kilohertz. So I also applied a decimation factor of 50, which effectively reduces the sample rate from 2.4 megahertz to 48 kilohertz. So this keeps only the useful voice band and removes high frequency noises. So then I have added a sample wedge. You can see over here. This simple switch block actually removes the background haze actually uh, when no one is speaking by muting signals below a certain power level. Then I have used uh, in the FM receive block within demodulates narrow band FM. The modulation is used most push to talk walkie-talkie systems. You can see the quadrant rate is 24 kilohertz, and also the audio rate is also set the same. But you can see the other two things like tau, which is set as 75 uh, microsecond, and the max deviation is 5 kilohertz, which was a default value, so I didn't change. So when I added it was same like this. Then finally I have added audio sync. The recovered sync is sent to the audio sync to a 24 kilohertz sample rate, so it can play through my speakers. So right now you can listen. Let me run the flow graph again, and we can listen the recovered audio. What is the actual audio we are supposed to recover? It's kind of taking a long time to run.
Good job. You successfully recovered the audio.
So here you can
Now make sure there is no static or noise in the signal.
So I have said I have in the uh, repeat I said yes, so we can listen it again.
Good job. You successfully recovered the audio. Now make sure there is no static or noise in the signal.
That was it. So this is the assignment from my group 4. So thank you very much for watching.